Today, the DS Incubator is going to be covering another section in the series of the targets package, and we are going to be talking about external files and literate programming. But before we do that, I want to say that we have a guest today. So CJ, can you introduce your friend, and Olga, then go ahead and talk a little bit about you?
Sure, thanks. So Olga is a former colleague of mine from the Hertie School of Governance and a dear friend for a long time. And I was talking to her recently and recognizing that she works in an organization where she's basically the only data scientist, so she's a bit isolated, not only with the pandemic, but also from that aspect. So I thought it might be interesting or fun to have her come join us, and she would have some sort of pseudo colleagues to talk about like tech cool stuff with, and also like she's really awesome, so I'm glad to have her here. And yeah, I leave the rest up to Olga to say which ones.
So hi everyone, and thank you so much for having me. And so I'm Olga. I'm a Russian citizen. I'm living in Berlin, in Moabit, and I work part-time for Zivitzen im Stifterverband as a data scientist, and another part I do lots of freelance work for various organizations. I've been working with R since 2013, since basically I met CJ, and I've learned quite a bit from him, and that's how we bonded, I think. And I'm very interested in various visualizations, mapping. Currently, I'm sitting on 2 dashboards and learning how to do all this e-charts in JavaScript, match it with R, and that drives me nuts, but it's also exciting. Yeah, so that's all about me. Thank you.
Welcome. So getting into the topic of the day, because these meetings are of very limited time. Basically, the objectives of today is to basically understand what the Drake jargon means when we say that a file is external or internal. Right now, it might not make a lot of sense, but you'll see that in a moment. And then we're gonna try to understand how to actually use these external files either as inputs or as outputs of our pipeline. But most importantly, I mean, this meetup is a response basically to the interest that I noticed in these meetings about this idea of, well, how a pipeline, a targets pipeline fits in, the different workflows that I may be doing in my analysis. So we have this idea, okay, in a repository, I have a bunch of code and I use that code to do more than one thing. So each of those things, we can call them a workflow. And we can, in our heads, we can think, well, a workflow is something I would explain in another Markdown file. So I wanted to demonstrate an example of an idea that I have been kind of suggesting, but never kind of showed concretely, which is this idea where, you can have a pipeline as a superset of computations, and from that superset of computations, you cherry pick the few ones that compose one workflow, and you do this one analysis with this subset of the superset, and that say is workflow 1, and then workflow 2 is you pick other targets, other computations, and you produce a different report. So, and then we're going to be also mentioning a topic that we'll be covering in another meetup in a little bit more depth. But it is this idea that targets is not just targets. It's a target belongs to a family of packages that is very quickly evolving, and it's called the Targetopia. In the same way that we have a tidyverse for multiple packages. By more or less the same people, Will also thought of this idea of a Targetopia, and we are going to be using for the first time one package of the Targetopia that is not targets itself, but instead is a package that builds on targets to create basically more readable pipelines, as you will see in a moment. So the motivational example of today is this idea of building 2 different reports. I'm going to be using a data set that comes with R. It's called the air quality data set. And let's pretend that we are interested in understanding, I'm going to start actually with this other one. Let's pretend that we are trying to understand the relationship between ozone and time. So we are pretend that we're interested with this question of whether or not ozone levels change through time for this particular data set. So there's many ways in which we could approach this issue. We can think of at least two approaches in which we can explore the relationship between ozone and day. And one approach could be just to produce a plot like the one that I'm producing here. This is kind of a spoiler alert, right? So I'm showing you already the results that we get from the data set. The uncertainty is pretty wide. Our line is almost horizontal. It can move in any direction. To me, just by looking at the plot, it suggests that there is no evidence of that ozone in this particular data set is changing through time. It seems pretty stable. So that would be kind of my very simple conclusion. So that's one workflow. I'm going to show you in a moment what data I used and how I massaged that data. And all those steps in the process are going to be targets very soon in a pipeline. But let me show you another report that I produced. In this report, I'm using just about the same data, almost the same targets, but I changed a few, not exactly the same. Most of them are the same, but some of them are not. So in this particular case, I'm studying the data in a different way. I'm just applying directly a linear model. I'm not plotting the linear model. I'm kind of again, I also see that the R square is very close to 0. There is a p-value that suggests that there is no significant relationship between ozone and day, and a few other parameters. So this is a summary of a linear model. And the conclusion that I arrive is the same, basically. But in our heads, we have a repository, we have data. I'm going to show you how I created the outputs in a moment. But basically, with the same repository, the same targets, I created 2 different subsets of reports, right, of analysis, and I'm explaining them in reports. So I'm going to show you what a full report looks like. Let's scroll up. It's a very simple R Markdown file. In this case, this is the report where I show you the plot. I'm setting this up by using the targets package and ggplot2. And also I wanted to kind of mention this quote that kind of inspires the way in which I'm writing this R Markdown document. This quote comes from the user manual of the targets package. And it says that the bulk of the computation, and this refers specifically to when you write R Markdown reports, the bulk of the computation should have already happened upstream. And most of the code chunks in your report should be just ters calls to tar read and tar load. And it makes sense if you're familiar with R Markdown. R Markdown itself has a great cache system. And you can say cache equals true, and that will save you some computations. But basically, you can get only so far with R Markdown's cache. Targets is precisely a tool to skip targets, to skip computations that don't need to be recomputed. So it is, it gives you the same benefits and a lot more, right? So if we understand that framework, then we can leverage its power and work with it super comfortably. So this is kind of also touches on a comment I think that CJ did a couple of meetups ago, and I was thinking about this quote that I remember I had read, but I didn't have it in my mind fresh at the time. So basically, how it works again, targets allows you to create all the computations in a pipeline. In a way that is quite readable, but then you have to explain why, what you did there, and the place to do that is an R Markdown report, for example. But because you already have all those computations done, you don't need to recompute them, right? You just pull them from the targets framework into the report and show the results. So, for example, in this particular case, the pipeline that I'm using, and I'm going to show it to you in a moment in R, directly in our studio, But the pipeline looks like this. You might already be familiar with what's happening here. The file that defines the pipeline is, usually, and this is like a review of the targets framework. We always start with a file. So targets needs a file at the root that is called _target.r that defines a project as a targets project. And it has a very consistent structure. You start first by attaching targets. And in this particular case, I'm attaching another package of the Targetopia family, which is called target types. And I'm going to be using this package here at the end. Then remember that you can set options either for the global environment or options for the global targets, for all targets. So with the function tar option set, we define options that are going to be passed to every target in the pipeline. For example, in this case, I'm using what we learned last time, that we could write functions, or we could write the functions that usually we use in the targets pipeline. We could just put them anywhere, or we could put them in a package and then use that package in the pipeline. So that's the approach that I'm using now, just as an excuse to practice what we learned last time. So I'm using the unfortunately, it looks like my voice is breaking a lot. Shoot, not very sure how to fix that. So bad. Let's see if this helps a bit. I'm gonna try use my earphones. I'm gonna hope for the best now. Can you hear me any better now? No? Shoot. Switch the video off maybe. Okay, that's a good idea. Let's switch the video off. Let's try now. If I'm also pulling from my internet is really bad. I think is that now any better without the video? Shoot. Well, I think I'll probably pretend that it's all fine and record it. Unfortunately, yeah, really bad. Okay, I'm gonna leave a little note here explaining what I'm about to do. Okay, so I'm super sorry, not sure what's going on. I'll move on and record. You may prefer to leave now and watch the video later. I know that's the only solution I gotta come up with right now. So I pretend that everything is okay. I'll do a recording, and then if you want, you can catch up with the recording later. Sorry, I have no better idea unless anyone suggests anything better now. So we were at the point where I'm explaining here the pipeline. So the next step is to explain what's happening here in the pipeline itself. We touch on the idea of what of using files that are external to the targets framework. When we need to read a file that actually we have in our computer, what we do is we basically create a target that the only thing that does is stores a path, and that defines that allows targets to know where to look for that file. So let me now jump to our studio, so to make this a little bit more live. Hopefully this will clarify things a little bit. So what we mean when we say that a file is internal or external is what we get is, so if we do if we see explore inside the targets folder, you will see that you might remember from previous meetups that there is a subfolder called objects. So that folder called objects has every target that is internal, that targets defined as internal, lives inside that folder. So as you can see, the targets that live in there, is data, lmfigure, lmfit, lmplot, and raw. So if I show you the pipeline now, so let me show you the pipeline, you will see that, so raw is here, data is here, fit is here, and plot is here. So these are all the internal files. Anything outside that folder for target is considered an external target, or an external file. And the way you use external files is that you need something that produces as output a path. So this function here, if I run it, you can see that all it does, it produces a path, and that will tell targets where to look for that file, as opposed to the default place, which is the objects folder inside the underscore targets directory. Another thing that you need to add there for that to work is the format argument, and you need to say format equals file. So that is what defines or what allows you to use in a pipeline an external file. Everything else here, I'm not going to cover it in much detail. It's something that we already used as things that we kind of covered in previous meetups. So like a requirement for today is, if you want to understand everything, it could be great if you watch other sessions. And if you're just fine kind of feeling a gist of what it is, this idea of external files and literate programming, then you should be fine. So just know that each of these calls is, defines the target. Here I'm defining the raw data is basically just reading from the path. Then we are creating a clean version of the data, calling a function called clean. Then we are creating a linear model by applying a linear model, right, to the data. And also we are creating a plot. If you remember from previous meetups, this, here to the left are all the names of the targets that we are going to be using. And here to the right, we have what's called a command. It is the expression that is going to be run by targets to compute the particular target here to the left. So we could have a quick look, for example, at fit.lm and see what that function looks like. So as I said before, it is a function that I decided to put it in a package, but it doesn't have to be that way. It is a very simple function. It just calls the function lm from the stats package and creates a linear regression between ozone and day using the data that you feed it here, right? So these two things you can forget for now. It's just a simple way to hack our command check to not get a node that is quite annoying. But basically, this is the core of the function. Fit.lm, that's what it does. So if you feed it with air quality, it will just calculate the linear model for that. So that is basically a quick review of the targets that I define internally. Then we already covered this external target, which we also used this approach before to read from external files. And finally, this is the most interesting bit for today. So this is kind of the core of today's meetup. And with this, actually, we are kind of getting relatively close to the end. In this particular target, what I'm doing is I'm using an external target, but not as an input, but instead as an output. So if I want to save a file as part of the pipeline, then what I need is a function that saves that file and outputs a path. So that's the requirement for an external output file to work with targets. So I'm going to show you what SavePlot looks like. It is a very simple call to ggplot2 ggsave. So a particular plot that you feed to this function will be first saved. But then notice that the function doesn't end here. It ends here. What it is at the end, it outputs a path. For, to comply with best practices, I use invisible, but, you don't have to. You could have, it could work just fine like that. That would be good as well. But because the main goal of this function is to produce a side effect, it is best practice to return the first argument invisibly as opposed to just visibly. So, okay, this is this function, what it will do, or this target, what it will do, with the target defined as it is here, let me show you, with this function will save the file in a directory called output plot.png, right? And the plot that will be saved is the plot that comes from the previous pipeline, that comes from here, right? So this is the plot, and this is the path. So if I now go to, basically, if I go to output here, there is a folder here, output, right? You can see that the plot lives in there, right? That's the plot that is used also in the report. And finally, it is also a great idea that, although you can render a plot using the button need, so say that I want to create this report, I can hit need as usual, right? And here I would have my report, right? But that's not as good as I can do. Instead, I can also do the same thing programmatically. And how? You can use the function tar render. And tar render will produce a target that is specifically focused to producing Markdown reports. And it comes from a package from the Targetopia family. It's called target types. And it's very simple. It just takes the name of the target. So now the report also is a target. And it takes the path, basically, where the file will be saved. Then there is a bunch of optional arguments that you can pass if you want to render, because the engine of this is Markdown render. And you can pass it through the ... argument. You can pass it any number of arguments that render will take. For example, output format equals empty document. So that means that when I produce this pipeline, let's do it. You might remember how this works. So we are now going to actually use targets. So library targets, right? And now we're going to do tar make, right? This will compute all my pipeline. So in this case, because the pipeline was already computed, it's kind of skipping every process, but I could do tar destroy and recompute, right? So now every target has run. The plot has been saved, actually, right? And the results will be that everything, including these two files, right, will be an output of the pipeline. So now my reports are produced programmatically. So I could open this report here, for example, right, and preview it. I think this is the button to preview it, right? And this is what the report looks like. And it was generated programmatically, right? Scrolling down, I'm gonna show you, here it is. For example, because the target LM plot holds a plot, I can just read the target with tar read, right, and simply show the result in the report. Again, as target says, an Markdown report inside a target's project is simply a bunch of calls, very terse calls to tar read or tar load, to just reuse the computations that the pipeline has created. Okay, so with that, I covered everything that I was hoping for today. We still have 5 minutes. Not sure if you will be able to ask questions. Let's hope for the best. So, do we have? If you could understand anything, could you have any comment, questions to end the meeting? Okay, I'm gonna type here a time. I'm guessing you couldn't hear a thing, right? Go ahead, Jakob.
So we could hear you. I think I could hear you at least. To be honest, I just need to digest this a little bit more to actually be able to ask about this. I think it actually points me into the direction that I would need to look to cover the different workflows and the stress testing repos at least. So yeah, I think that will be helpful. But yeah, I will for sure need some more time for that.
Perfect.
But thanks. Yeah, it was really cool to see that this is covered.
Thanks. Notice that each meetup exists here in the DS Targets repo. So you can go to this repo when you want to review, and notice that there is releases. So each meetup has a corresponding. This was last meetup. This was the previous one. This is the other one, right? So if you want to review a previous meetup, you can just check out the different tags and travel back in time to see the project exactly as it was the day that the meetup was delivered. Today, for example, you have here is like the LM, for example, targets. So you would have access to this and you can consume it at your own time. Do you have any more comments or questions? No more? Okay, then I will kind of wrap up with a quick summary of what we have covered today. So today we covered this idea of using targets as basically the engine that will produce computations, and then using those targets inside different reports. I'm arguing that a targets pipeline can be thought as a superset of computations from which we can cherry pick subsets of computations and explain those subsets of computations in different Markdown reports. The result would look like, for example, like the file that I'm showing here, where I have one file called, in this case, LMMD, that explains my workflow for understanding if a zone levels change through time using a linear model. And then I have another workflow where I do something very similar, but instead of using a linear model, I use a plot. So both reports have a lot of overlap, right? And that also means that I can save computations by leveraging the power of targets cache. So I create the targets pipeline with tar make, and then all those targets are ready for me to reuse in different reports. And I produce those reports simply as like very terse calls to tar read or tar load, where I'm pulling the computed targets from the targets framework and just showing what they are in the report. And thus my report runs like very quickly. Okay, that's bringing us close to the end. I'm super sorry for the issues with my sound. I think the problem is my internet connection. I put in from my phone. Do we have any parting notes or comments before we leave?
Yeah, I have one question, comment. I kind of understood that the targets thing, like the R Markdown files rendering themselves, would be also a target. So it's kind of like feels unexpected in some way that then inside of the R Markdown file, it's then reading in archived targets files or something. I don't even really know the right words to talk about this thing.
Yeah.
Do you know what I'm saying?
Maybe I'm not sure if I was clear explaining this really. So the reports are normal reports, so we could, if we wanted, need them manually. But depending on how many reports you do, for example, you might want to instead render them inside the pipeline. So you don't even need to hit the init button. So I haven't covered it today because it's a bit advanced, but we could be using parameters, for example, in our Markdown, and map those parameters to like a very large number of reports. So say that we wanted to compute ozone layers for different countries in the world, and we have a data set of 300 countries. I mean, to meet 300 times would be silly, and we can just tell targets to do it for us. We can write a pipeline that creates all those 300 reports right away, right? So once we figure out one, we can just map those to like the different countries that we have in the data set or something like that.
Yeah, cool, thanks. I think after I said that, then I realized it is doing kind of what I expected to do.
Yeah.
Because using this tar archetype tar render is essentially making a target, which is like the rendered output of that R.
Exactly, the output of this target. Unfortunately, the target has to have a name, but it doesn't make a lot of sense because then the output is gonna be basically an empty file in the root of my directory. In this case, this one. In this case, plot. Right. So this is the output of this particular target. Yeah. In any case, you know, as we move through targets, you know, I realized that it's a very complex tool, very powerful, very flexible, quite user-friendly, but it does need a lot of time. I am now super excited. I'm learning so much, but I also realize how much you have to get into these things to understand, you know, why you even would want to use them. So I guess that my very humble goal would be for you to be exposed to all of this, not hoping for you to even remember how to do it. But I'm hoping that if at some point it feels like, okay, actually this is the kind of thing that I suspect targets could be useful for, then, you know, you can check in with me or you can go back to the targets repository and kind of serve yourself to solutions. So with that, I think we need to kind of wrap up now. And I would like to end just saying thank you again, Olga, for joining us. You joined us in a meetup that is very advanced in a series, so I'm not hoping to, maybe I lost you in the first 2 words, but yeah, just having you here is a privilege. Thank you very much. Ciao, ciao.
Thank you. Ciao.
Thanks, bye.